that'll cover today's material as well as yesterday's. Okay. I know you're looking forward to that. This is usually one of the tougher things for the children in Algebra 1 to comprehend. Not because it's overly complex, but it does require the following of some rules. And then kind of the other thing to consider is starting Thursday it becomes obsolete. Because everything that we can do by completing the square can be done by quadratic formula, and quadratic formula is just much more efficient. It gets us to where we need to get to with less of a hassle. But there could be some questions on the EOC where they word it creatively to force you to complete the square. If all you're being told is to solve a quadratic equation, no, there's really no way for them to monitor how you solve it, so you can pick whatever your favorite method is. But if they ask you for instance, hey, what number completes the square, then you'd have to know how to do this skill. I will have some questions like that on the quiz and on the test. Since I can't force you to come on a test, if I tell you the directions are gonna say solve however you want, so I'm guessing nobody's gonna choose to solve by completing the square, but there will be some questions that only ask you to complete the square. I'll show you what I mean. In order to complete the square, you have to understand what we did yesterday. What was it that we did yesterday? What bright shine? Yes, we did. We did do square root property. And what did square root property tell us to do? Stuff? No, it didn't say stuff. What did square root property tell us to do? As 23 hours and 8 minutes ago. Yeah, but we already knew how to solve. But it was part of that solving process that. But when you took a square root in an equation, what did you have to remember? And I would ask you guys, hey, what's the square root of this? And then you guys would say a bunch of numbers, and I would just wait and wait and wait, and then somebody would go, oh yeah, that's right. And then they would put something in front of it. Thank you, a plus or minus. So square root property taught us that when we take a square root in an equation, we have to stick a plus or minus in front of it. But we also prefaced the lesson at the very beginning and said, hey, this property only works under certain conditions. What were those conditions condition that was set forth at the beginning where square root property was viable? In order for square root property to work, this had to be true. Yeah, that there was no B term. So all we're really doing today by completing the square is taking an equation that does have a B term and rearranging it so that we could use square root property. Before we begin any steps, what we want to look for is a PST. And you're like, what the heck are you talking about, Mr. Romero? What's a PST? And you shouldn't be saying that because since we covered factoring the last 2 weeks. No, you no sé. Since we covered factoring the last 2 weeks, even somebody in my first period remembered, believe it or not. What does a PST stand for? It's an acronym that pertains to a type of factoring. Sorry. The T does not stand for term, no. This is fun. I like this game. I want to guess. What is a PS? Very good. Perfect square trinomial. What's going to get that B term and turn it into something that's manageable, another way to think of it is When you have a b term, you have two different types of x's. So what's going to get the two different types of x's and turn it into a single x is that we need a perfect square trinomial. If you remember, a perfect square trinomial was just one parentheses with a square, which is what we saw yesterday. But there were some requirements in order to have a perfect square trinomial, and this is what we're going to be checking for at the beginning. This hardly ever works, so don't get too excited about this. More than likely, you're going to have to go into the steps. But the first and last term in the trinomial have to be positive and perfect, and then the last check would be to make sure that b squared is equal to 4ac. If that's the case, then we can skip all the way to step 4. Because that is the purpose of this process, is to obtain a perfect square trinomial. If we have one at the beginning, we can skip a bunch of stuff. But let's say we don't have it. Well, then the first step is going to be the same as the first step yesterday. This is in the same family as square root property. Emma B. Do you know what EGB stands for? Stands for Emma Grace Brown. So anything with a variable on one side of the equal sign, any constant on the other side, just like we did yesterday. But remember that if you can, I told you and I warned you, this is probably one of the tougher things to understand in Algebra 1, but I'm trying to kind of give you a macro approach where if you understand the process as a whole, maybe that'll help you understand the bits and pieces. Overall, what goal are we trying to accomplish? As said by Jason Babb. What goal are we're trying to get a perfect square trinomial, which has certain requirements. First term, positive and perfect. Third term, positive and perfect. And then this whole b squared is equal to 4ac. Well, once we have the variables on one side and the constants on the other, we're going to focus on the side that has the variables. The second step is what causes that first term to be perfect. If the first term, the a term, is already perfect, well, we can at least skip that step. But this step 2 here revolves around the first term. If it isn't perfect, then we're going to make it perfect by multiplying everything by a. Now, this kind of deviates from most textbooks because I've never seen a textbook that teaches it this way, but I do it for the children because it makes their life easier. Every book that I've ever seen on this step tells you to divide. But why don't we like division if we don't absolutely have to divide? What ugly circumstance? What yeah, division can cause fractions. Division can cause fractions, but we don't like fractions, so this is another alternative to multiply. Once we get this far, the next step, this is where the whole process gets its name. We are going to complete the square, which is completing the square is going to create a third term for us. The first and the third term in the perfect square trinomial have to be positive and perfect. This is going to create a third term, and this is the formula that I use. This is the only formula that you can use if you multiply on step 2. If you divide, and I especially bring this up in this situation since about half of you had a different teacher for the first half of the year, for the first semester. If you divide in step 2, then you're also allowed to use that formula. Maybe you might recognize that. But see that if you divide up here, what you end up doing is dividing a by itself. What's anything divided by itself? It's 1. So when a becomes 1, then you can use this. But if not, as long as a is perfect, which is that's what we're going for, then we would use that. That's going to complete the square. Even if I can hold your attention for for more than 5 minutes at a time, and you follow me up to this, and you get this, like you kind of understand what we're doing, you're able to do this. The silly mistake that people do is this part. They forget they have to add it to both sides. Everybody remembers to add it to the side with the variables. They forget that they have to add it to the other side. Well, at the very beginning, we started with a check. And that check said that, hey, if I have a perfect square trinomial, I can skip to step 4. Well, step 4 is what's coming next. And if you did step 2 and step 3 correctly, you will have already a perfect square trinomial. So now is when we factor it. We jump in our time machine back to 2 weeks ago where we learned about perfect square trinomials. And we would factor it. That's when you do the whole one parentheses with the square thing. Besides having one parentheses, where this step is going to help us, is it's also going to get us down to one variable, which is what we wanted. And then we can also jump in our time machine and go back to yesterday, because since we'll be down to one variable, now we can use square root property from yesterday, where we couldn't before. Let's let the festivities begin. You smell like salami? We had a sandwich party before school. Hope you seem troubled. Okay? You don't like completing the square? You just work on showing up on your birthday. That's good. All right, so here we go. Let's solve by completing the square. What does the first step say to do? Or better yet, what does the pre-step say to do? No, what is the like before we start doing any steps, if we want to be as efficient as possible. I don't know, you mumbled. You were all over the place. Jesus. Yeah, let's see if we have a perfect square trinomial. Look, and we do have 3 terms on one side, so it's possible. And the first term is positive and perfect, but sadly, the third term is not. And those are the ones that we would need to be positive and perfect. The third term is neither positive or perfect, so we need to embark on our journey. So go ahead, Taiwan. Go ahead and give me that first step again. All right, so any constants, I send any constants away. This -3, you did me no good. You are bad and shed. Daddy, are you trying to be like Soha? So now we have x squared plus 6x is equal to 3. So now we're able to move on to step 2. What does step 2 say to do? Or if you were listening, you can paraphrase for me and tell me what we're trying to accomplish in step 2. Perfect square where? The second step tells you to focus on the first term. We need to turn that first term into a perfect square, if it is not already. If it isn't, then we would multiply everything by a, and it'll magically become a perfect square. But, luckily, it already is a perfect square. What times itself gives you x squared? 1 times 1 is not x squared. X, yeah, x times x. Good. So that's taken care of. We can now move on to step 3. Step 3 says, hey, this stupid -3 here didn't do for me what I needed it to do, so I'm going to create a number that does for me what I needed by completing the square. So the formula for completing the square, I'll write this one time for you today, is b squared over 4a. That's what we're going to use to manufacture the number that we always wanted. So this is going to be 6 squared over 4 times 1. 6 was b, the 1 was a. That gives me 36 over 4, which gives me 9. If only that 9 was there, then all my dreams would have come true. But you know what? I'm going to take care of that. I'm going to put the 9 there. And because this is an equation, I can do whatever I want as long as I do it to both sides. I'll even color code it for you for a more dramatic effect. In red, we have the equation that you saw before we completed the square. And now in patriotic colors, we have what I did to both sides, which is I added 9. By completing the square, you are now guaranteeing yourself that PST. There's no need to check for anything. We don't have to do b squared equals 4ac. We know that on the left side, we're going to have a perfect square trinomial, so we can factor it. This is step 4. If you remember factoring, that's 1 parentheses with a square on the outside. Keep the sign in the middle. What sign is in the middle? What sign is in the middle? Now let's look at those perfect squares. What times itself gives you x squared? What times itself gives you 9? On the right side, 3 plus 9 is 12. What's different about this line and anyone that came before it? Okay, fine, there is a parenthesis, but more than a parenthesis. What are we trying to solve for? What are we trying to solve for? What are we trying to solve for? What are we always trying to solve for in an equation? The variable. Well, what's different about the variable here versus the variables above it?
It's square. It's not square. It's not square. I mean, no.
What's different about the variable there as opposed to the variables that came before it?
There's only one.
Yeah, there's only one. I like it better though.
But you won't let me sit there.
Right.
But you'll let me.
It's because I like you so much that you have to stay in your seat. There's only one single x, which is good because now we can go back to yesterday, and if you understood square root property, it's time. That was another square root. The square root will get rid of the square, so we have x plus 3. Now we can't forget square root property. What did we learn yesterday about square root property? Is that your phone? I wrote a referral last period for phones. It's been a while. It's been like over a month. No. It was Emma Grace. Very good. Well, it is a plus or minus, but here's another thing that crappy Romero didn't help us with yesterday. Yesterday, conveniently, on the other side, all the numbers were perfect squares. OP. Here, the 12 is not. So we have to go back and remember the first month. When you had a number that wasn't a perfect square, what do we have to do? Factor tree, good. I can bring out a 2, a 3 stays inside. Don't forget the plus minus. That plus minus still has to be there. Jocelyn, that you were doing good back then, so you look worried about the factor tree. You remember the factor tree, right? Okay. Has the x been isolated? No. Is the plus minus there? Yes. So yesterday you learned that when that's the case, that you should split it into 2 equations. And you can. I used to force the kids to do it. But the truth is, and I just got tired of kids calling me out on it, that I said, you know what, fine. No, it's not about being rude. You didn't question. Nothing rude about questioning something that's on the board. See, I have a dilemma, right? So I taught you that split it. It's not solve for split it. But now I'm about to show you, well, in this case, you kind of don't have to. Well, that causes confusion. But Mr. Romero, how come yesterday you split it, but this time you didn't? I don't know. I don't get it. I'm so confused. So, you lose out Yeah. So we miss out on the uniformity of it because in order for you guys to learn, must do same thing every time. But the reality is, for the people that have a better grasp on things, what's different about this problem and the ones we did yesterday, besides the steps that came before, is that stuck around. Yesterday, all the numbers are perfect squares. So what happens is, even though we have steps left to do, the only step left to do is eventually going to be to do minus 3. I'm not going to be able to combine it with that radical. So splitting is not going to help me. You can do it. I'm not telling you not to do it, but splitting is not going to achieve anything. So you could just leave it like this. Just understand the reason why I'm leaving it like this is because the radical's still there. Elsie. Because the radical's still there, I'm leaving it, and then we'll just worry about isolating. Now the x is by itself. You will see the -3 written first. Typically the plus minus and the radical come next. And now we're done. Because the radical is there, if you were to use a calculator, you would get a decimal. But because the plus or minus is there, that still means there's two solutions. If you put -3 plus 2 square root of 3 in the calculator, you're going to get a decimal. But if you put -3 minus 2 square root of 3, you're still going to get a decimal, but it's going to be a different one. There's still two distinct solutions. Super.
Nice.
Muy bueno.
No, espérate,
Oh, hey. Dale que yo puedo. All right. First step. First step. First step. First step. Hey, let's check. Heck no. Whoa. Yeah. Let's see if we can save ourselves some work. This will hardly ever apply. You're never gonna hardly be this lucky. But, geez, if I look on the left side, not only do I have 3 terms, but the first and the third term are positive and perfect. If I somehow just trip and stumble upon a perfect square trinomial, I can skip all the way to step 4. Me likey. Now the good news is if you just say, hey, look, I'm going to concede that forget it. I hate math. I'm going to have to work at this no matter what. And you want to start off subtracting 225, go ahead, but then you're going to have to go through all the steps. Whereas if I'm disciplined, and then I go ahead and do my check, remember b squared is equal to 4ac. b is -30. 4 times 1 times 225. Yeah. -30 squared is 900. And so is 4 times 1 times 225. Want to sit closer?
Pull it right here. Give her the trash.
So what happened is instead of me having to manufacture my own perfect square trinomial, I was blessed to have one already. So I'm going to go ahead and fact a perfect square trinomial. It's still 1 parentheses with a square. I'm not going to have to touch the right side, so that's still going to be 400. I'm going to keep the sign in the middle. What sign was in the middle?
Well, there's a negative and a positive.
What sign is in the middle?
That's not the middle, the plus is in the middle.
No, the middle term. The middle term is negative. Whatever sign the middle term is. The middle term. Second term.
But a plus can be in the middle term.
But in this case, it isn't. So, and now we need those perfect squares. X times x is x squared. What's the square root of 225?
5. 15.
Hey, look at that. Without having to do all the same work from the first problem, how many x's do I have now? Let me like you that. Okay. So I can go ahead and get rid of the square now by using square root property. I was able to get rid of that b term, BGB. X minus 15 is equal to 2. Very good, plus or minus. And here I do get lucky that 400 is a perfect square. So Emma Grace, do you still see a radical? I don't know, I was taking a break, but now that yeah, there is no more radical. Has the variable been isolated? So let's go all the way back to yesterday then and split it. X minus 15 is equal to 20. X minus 15 is equal to negative 20.
Wait. Oh, never mind.
Okay. And this is an attention thing. This is not because it's hard. Just that you guys are all, your attention is 800 different ways. Last problem was not able to get rid of the radical. So it isn't that I couldn't split it. It just didn't do me any good. I wouldn't have been able to do anything extra by splitting it because that radical stayed. On this one, do I still have the radical? No, I was able to get rid of it completely because the square root of 400 is 20. So now when I do split it, well, look, I can actually do stuff. Plus 15 plus 15, x is 35. Plus 15 plus 15, x is negative.
Yo nunca pensaba que usted puede hablar algo de tanto estudiar matemáticas. Yo tuve un socio que se costó por estudiar matemáticas. Se volvió loco.
Yeah, I'm already local. So there is more than one solution. You should write a solution step. I mean, C.
I like the plus or minus.
Well, you also weren't here yesterday. Did you watch the video? It's on your bucket list. Okay, good. All right, let's do this one together. First step or pre-step. Well, the first thing you should be checking for is a perfect square trinomial, regardless of what's on the other side. Xavier, I can see it now, so you can't say you don't have it out. So would you like to put it away? Or should we go the referral route? Thank you, sir. Even though the first and last term are positive and the x squared is perfect, 3 is not a perfect square, so whether Elsie knew that ahead of time and she stumbled upon it, she is correct. The first step is to do minus 3. So where that 3 failed us, eventually we're going to put our own perfect term that we wish would have been there. But before I can get there, I need to go look at the second step. Says, hey, let's make sure everything is kosher there on the first term. Is that a positive and perfect?
Yep.
All right, so then we don't have to touch it. So now let's go to the third term. Okay, how can we create this this term that we wanted all along? B squared over 4a. But sadly, in this case, because b is 5, look at what's going to happen. Oh no, it's a fraction. Yeah.
We don't like that.
We don't. But unfortunately, we have to deal with it here. So the oh look, I told you at the beginning that for the most part, including on my test, once we get to the unit test next Tuesday, when you're told to solve an equation, you're gonna have. It's very difficult to try to force you to solve a certain way, even if the directions tell you to. Like once you learn quadratic formula, if you solve this equation by quadratic formula, you're going to get the same thing that you would by completing the square. So the only way that they can really kind of force you to know how to complete the square is not to ask you to solve, but to ask you, hey, what number completes the square? I'm going to have some like that on the test and the quiz tomorrow. If I ask you what... Yes. If I ask you what number completes the square, what would you tell me? What is the number that completes the square? It's the last number I wrote on the board. No, not 5. 25 over 4. This is the number that, this is not the solution. That's not what x is equal to, but that's the number that completes the square. If I ask you on this one here, oh, actually I didn't have to here. If I ask you on this one here, what number completed the square? What number completed the square on the first one? No, 9. Yeah, the 9 is what completed the square. So that's really the only way that they can force you to know about completing the square. Is instead of asking you for the solution, they would ask you what number completes the square. Just keep that in mind. All right, so now that I have a completed square, what am I supposed to do with that 25 over 4? What am I supposed to do with the 25 over 4? What am I supposed to do with the 25 over 4? What am I supposed to do with the 25 over 4? What am I supposed to do with the 25 over 4? What am I supposed to do with the 25 over 4? What am I supposed to do with the 25 over 4?
Plug it in on both sides.
Yeah, add it to both sides. In red, I'm going to write what was already there. And now in blue, I'm going to write this completed square. Even though we don't like fractions, since we followed our directions the way we're supposed to, we are now guaranteed a perfect square trinomial. So on the left side, I can write one parentheses with a square. What sign do we have in the middle? A plus, so I'm going to keep a plus. Even though we don't like fractions, one operation that's not too evil with fractions are exponents and radicals. It's not too bad. Watch. What times itself gives you x squared? X, right? But then when I ask you what times itself gives you 25 over 4, it's not a big deal. Just take the square root of each number. 5 over 2. 5 times 5 is 25. 2 times 2 is 12. Yeah, we're a little bit close. About 2/3 of the way there.
We have 9 more 2/3.
Oh, we're not going to finish all of those ones.
So it was a plus 5x equals negative.
Well, yeah, now the operation that we don't like with fractions is adding. Because now we have to remember that this is 3 over 1. What is the least common denominator of 1 and 4? What's the LCD of 1 and 4? Correct. Want to ask Jerry? Jerry Berry, LCDs are his specialty. What is the least common denominator of 1 and 4? If I want to have a 1 and 4 to have, yeah, it is a 4. Because the 25 kept its 4, it gets to keep the 25. 1 times what gives you 4? 1 times 16 is 4. 1 times blank gives you 4. Times 4. So in order for this 1 to turn into a 4, I have to multiply by 4. I got to do the same thing to the 3 on top, which gives me 12. What is negative 12 plus 25? What is negative 12 plus 25?
13.
13, good. Plus 25. Isaac processed it.
You said 13.
All right. Well, for the last 2 steps, I've been down to 1 variable. Me so happy. So square rooted x plus 5 over 2 is equal to. Oh no, I have to take a square root of a fraction. It's not that bad. Just take the square root of each one. 13 is prime. Square root of them won't work, so that's going to stay the same. What's the square root of 4? 2. And then, as always, you can't forget in front plus or minus. How much you love math? No, you're on your birthday.
Did you do it backwards?
You're backwards.
No, I mean like this semester. Didn't we do this close from the beginning?
Now, we were probably doing this maybe right before Thanksgiving, but which was about a month. Which was right about okay, which was, and after Thanksgiving we had a month left until the end of the year. How much do we have left until the end of the year now? About 5 weeks. So.
Thank God, no
Did the square root survive? Did the square root survive? Yes, it did. So their splitting is not going to help me. So since I still have a square root, splitting is not going to help me. I just went ahead and subtracted already. You should write the plus or minus second. So I'm going to write -5/2 first, plus or minus square root of 13/2. Especially in your case, since you're blessed with a teacher that gives you mostly multiple choice on assessments, I should let you know that it is possible to see the solution like this way, but another way you could see it, since both fractions have a 2 on the bottom, they could merge those 2's into a single denominator and just write -5 plus or minus. Because the plus or minus is there, it still counts as 2 solutions.
So that only works.
Yeah, I mean, I guess you could make the denominators the same, but yeah, this is 2 different ways that you could show it.
Do you think they would do that in tests and stuff?
It's possible.
They would just make.
It's possible, but once you learn quadratic formula on Thursday, all of this stuff becomes null and void because it really gets done for you. What quadratic formula does for you is it just gives the x by itself already. So, and then the other side, you just got to simplify and it'll take care of itself. It also makes dollars. All right, here we go. What? You didn't find tape? You're looking for tape?
Wait, you made this? And you're great. We had a week of things to do, so you made this like on a Saturday. Why do you do work on weekends?
Because I have no life.
That's so sad. Do you have a son?
Wait, you have a son?
You should
Oh,
take your
no, but
son.
Miami do it.
Take your son. Take your son.
Miami Beach, man.
When's your son's
Take your
birthday?
son to go home.
Crazy, bro.
We do not have a perfect square trinomial here because we don't even have a trinomial. So we're going to have to start our steps. But luckily, the first step is taken care of for you. The variables are on one side, the constants on the other. But unlike the last 3 examples, my first term now is not perfect. So I have to make it perfect. How did I tell you to make it perfect?
Just be yourself.
Just to be yourself. How do you make the first term perfect?
-4.
How do you make the first term perfect? Step 2. It's like literally written, like it's printed for you. You shouldn't have to guess because it's written right in front of you. No, you went too far. You're right. Both variables are on one side, so I'm on step 2.
If it's not,
I need to make the first.
square, then multiply both sides.
Thank you. Multiply earthing by A. A is 3.
Oh my gosh. Dude.
So now we have 9x squared minus 12x equals 6, and conveniently 9x squared is perfect.
You wrote it.
No, you wrote it. So now we need to work on that third term because we're trying to manufacture our own perfect square trinomial. Now is where we would use that b squared over 4a that Elsie was talking about. -12 squared over 4 times 9 is 144 over 36. Okay. So 4 is going to be the number that completes the square here.
36 goes on a 1.
Yeah, 4 times. Fax machine.
Oh my god. Give your beat that.
So 9x squared minus 12x. And here was a 6, but then I can't forget I had to add the 4 to both sides.
But
By following all my steps with a fine-tooth comb, I am now guaranteed a perfect square trinomial. So on the left side, 1 parentheses with a square. On the right side, 6 plus 4, use your fingers, is 10.
Wait, you put a negative, no, minus.
I will keep the sign in the middle, which is minus. What times itself gives you 9x squared?
Yeah, that's
3x. What times itself gives you 4?
Oh, yeah, oh my god. 4 times 4, yeah. I'm so sorry.
So for the first time, we're down to a single x. If I were to give you this problem, this is something that, if that would have been the problem, that's something I could have given you yesterday. You would have known how to solve that yesterday. So let's go back to our yesterday skills. Square root of 3x minus. Okay, you are correct. If you put square root of 10 into a calculator, unless you have fancy math print, it's going to give you a decimal. And when you put 10 into a tree, there's no pairs. So even though 10 is not prime, and I still need the plus or minus, when it stays square root of 10. Was I able to get rid of the square root sign? No, so splitting is not going to help me. Do it if you want to, it just is not going to help you. So I'm going to leave it like that, and let's just continue with our internal quest to isolate the variable. Plus 2. So 3x is equal to 2 plus or minus square root of 10. What's the last step to get x by itself?
divided by 3.
Divide by 3. Now we're done. Usually on the computer, what they would do is split it into 2 separate fields. So you would just have to write it twice, one with a plus and one with a minus.
We're just writing like 2
What's the difference between this and the last one that we did?
What's the difference between this and yesterday?
No, like 2 weeks ago.
2 weeks ago we did factoring.
Yeah.
We're doing the same thing. We're solving quadratic equations by using a different method. If we were to have more time to converse, I would show you how factoring, which is what you learned before, only works if your solutions end up being rational. You see how this solution ended up with this, with a radical? That tells me that if I would have tried factoring, it wouldn't work. Go back to the beginning and go back and try to solve this equation I gave you at the beginning. Well, by putting everything equal to 0, and blah, it won't work. Yeah, but you won't know that until the end. But correct. If I end up with a radical, that means that factoring would have never worked in the first place.
So even if you try factoring first, it would just.
All right. So like the last period, I was able to let them do this, but we're gonna have to do this together, and hopefully I can knock out 2 more. First step: check for a perfect square trinomial. Even though we do have a trinomial, Jonathan, why is it not a perfect square trinomial? Yes, Emma. 3 is not perfect, so let's move it to the other side, and then we'll bring in our own better third term. Now the good news with this one is that at least the first term is perfect and positive, so we can jump straight to completing the square. When we're not done, we gotta complete the square first. Complete the square is b squared over 4a negative 4 squared over 4 times 1. Which is positive 16 over 4. If you are asked only for what number completes the square, you would say 4. I'm not saying that x is equal to 4. That's just the number that completes the square. So we're going to get that 4, that magic 4, that we wish we would have had at the beginning. And I'm going to write it on both sides. Now I hope you can write the parentheses, and you are right, it will have a minus in the middle, it will have a square on the outside, and on the right side, negative 3 plus 4 is 1. What times itself gives you x squared? What times itself gives you 4? What am I forgetting? Very good, plus or minus. Actually, wait, I'm sorry, not yet. Just kidding, sorry. Oh no, I got confused here because what's the square root of 1? Yeah, so like, yes, my next step is the square root, and I'm gonna end up with the same one, but yeah, now it's plus or minus. Sorry about that. Getting ahead of myself.
It's okay, no, it's fine. You gotta always jump your head sometimes.
Yeah, get ahead of myself. Did the square root survive?
Yeah, no.
It did not, so now we should split it. X minus 2 is equal to 1. X minus 2 is equal to negative 1. And even though we're really bored, we survived to find out that x was 3 and that x was 1. You okay, Johnny? Jay Jizzle? Last one. Here we do not have a trinomial, and Taiwan's excited because the 9's already on the other side. So we got x squared is also positive and perfect. So here we can jump straight into completing the square. Okay. Well, look, hey, Jason brings something up. He's like, look, but Mr. Romero, how about if I were to add 9? If I do that, then my first and last will be positive and perfect. But look at, you still have to test out to see if b squared is equal to 4ac. And this would have to be 10 squared is equal to 4 times 1 times 9. Is 100 equal to 36? No. So, but I mean, I'm glad you're thinking like that, but no, it's not going to help. We're going to have to complete the square ourselves. So if we're completing the square, b squared over 4a, which is 100 over 4. Okay, so it isn't 9. What's the number that would have completed the square? What's the number that completes the square? What's the number that completes the square? What's the number that completes the square? 36. So I'm going to get that 36 and add it to both sides. Actually, I'm going to do it. Sorry. What's the number that completes the square? 25. My bad. 100 divided by 4 is 25. But now I got to get that 25 and add it to both sides.
Yes.
One parentheses with a square. What sign in the middle? Plus. This is an x. This is a 5. How many x's do I have? How many x's do I have? Plus 1, so I can now square root it. What is x plus 5 equal to? Plus or minus 4. So x plus 5 is equal to 4. X plus 5 is equal to negative 4. Remember that you have a homework assignment this week that you can practice.
Yes, sir.
Yeah. Yep. You can split all of them. You just don't need to do the other ones.
Well,
Yeah. This one you do need to, yes. Well, you're probably gonna miss out on at least one of the solutions, yeah.
if what it equals to is 1 square root, split it, right, mister?
You can split it, it's just not gonna do anything for you.